Okay, so perpendicular lines. Lines that intersect at a right angle are called perpendicular lines. Now, if you remember um, from any type of geometry, a right angle makes a perfect corner. Sometimes they put the little box in there, and it represents a 90-degree angle, makes a perfect corner. Um, that would not be a right angle there because it doesn't make a perfect corner. Like these corners are way bigger. These angles are way bigger than these ones. Okay, so just remember, right angles um, are, are formed by lines that intersect, and those lines that intersect would be perpendicular. Right angles are 90-degree angles. So the slopes of non-vertical perpendicular lines are opposite reciprocals. So what that means is that you take the number, if it's not a fraction, you make it a fraction, flip it over and change the sign. So opposite reciprocal of 4 would be negative 1/4. If it was negative 3/7, the opposite reciprocal would be positive 7/3. If it was 1/3, the opposite reciprocal would be negative 3/1, or you could just write it as negative 3. Okay? In the example they did, if the slope of the line is 4, you can write it as a fraction by putting it over 1, flip it over and change the sign. Okay? So perpendicular lines have slopes that are opposite reciprocals of each other. So vertical and horizontal lines can be perpendicular, but notice if you have a horizontal line, the slope would be 0. Okay, if you put it over 1 and flip it over and change the sign, that doesn't really make sense because you're dividing by 0. So that's why that they say that the slopes of non-vertical perpendicular lines are opposite reciprocals. If you have a vertical line, you can still have another line that's perpendicular to it. It's just going to be horizontal. Okay, so that's why they say that. All right. So you can use slope to determine whether two lines are perpendicular. So the outline of a company's new logo is shown in the coordinate plane. It's like a square with a couple of triangles and weird lines in it. All right, so is DFE, the angle DFE, a right angle in the logo? So how you identify an angle is you just follow the letters. You go from, let me do it in red. You go from D to F, and then F to E. And I want to know, does that make a right angle? Okay, so how do we figure that out? Well, the two lines that intersect are the line BE, so from B to E, right here to here, and A to D, right here to here. So if those two lines are perpendicular, then the angle at which they intersect, DFE, is a right angle. So what we have to do is find the slopes and compare them. If I find the slopes and I find that the slopes are opposite reciprocals, then I know that those two lines intersect at perpendicular or intersect perpendicularly, and therefore the angle is going to be a right angle. Okay, so the slope of BE. Now if you look at B, point B has coordinates 2, 3. And point E has coordinates 7, 1. All right, so if I do y2 minus, we got to put the E on there, y2 minus y1, or 1 minus 3, over x2 minus x1, 7 minus 2, I get negative 2/5. Okay, then I got to do the line AD. Well, A has coordinates 2, 1, and D has coordinates, let's see, 2, 3, 4, 4, comma, you got to go up 1, 2, 3, 4, 4, 6. Okay, so the slope of AD, I would do 6 minus 1 over 4 minus 2, or 5/2. Now, if I compare them, the line segments are perpendicular. Now, if you multiply two numbers and the answer is negative 1, that means that the numbers are opposite reciprocals. That's one way to prove it. Or you could just look and see that one fraction is the other fraction flipped over with the sign changed. That's what the opposite reciprocal would be. Okay? Is each pair of opposite sides parallel? Now, opposite sides, would be parallel if they have the same slope. Okay, so now we're kind of going back to switching gears and going back to questions about being parallel. Well, if I have AC, so we're talking about the opposite sides of the outside border here. So AC, if I get the 2 points, A is 2, 1, and C is 2, 6. If I get the slope there, you could see that it's a vertical line, so its slope should be undefined because 6 minus 1 is 5, and then 2 minus 2 is 0. So anytime you're setting up a slope form and you get to 0 in the denominator, you know you're going to have a vertical line. So the opposite side, GE, also has an undefined slope because it's a vertical line. And since A, C, and GE are both parallel to the y-axis, they are vertical and are therefore parallel. All right, we got to do the other pair now. The slope of CG, this line, you could tell it's horizontal, so you should end up with a slope of 0. And if you get the 2 points, 2, 6 and 7, 6, when you subtract, you would get 0 over 5, which is 0, so the slope is 0. And then GC and AE are both parallel to the x-axis. They are horizontal and therefore parallel. If the lines weren't parallel to the x-axis or the y-axis, you would just get the slope of the two lines and make sure they had the same slope. So if I get the slope of AE and CG, both of them are going to be 0, so they have the same slope, so they're parallel. If I get the slopes of AC and EG, both slopes are undefined, so that's the same thing. Therefore, they're going to be parallel as well. All right, so on the plans for a treehouse, a beam represented by QR has endpoints -6, 2 and -1, 8. A connecting beam represented by ST has endpoints -3, 6 and -8, 5. Are the beams perpendicular? Let's explain that. Go ahead and try this one and pause the video. All right, so first thing we should do is plot the points. -6, 2, -1, 2, 3, 4, 5, 6, up 2. It's going to be right there. And then -1, 8. So to the left 1, up 8, 1, 2, 3, 4, 5, 6, 7, 8. So right there. So this beam is right here. And then the other one is -3, 6. 1, 2, 3, 4, 5, 6. So right here. And then -8, 5. 1, 2, 3, 5, 6, 8, 1, 2, 3, 4, 5. And that's the other one. It already kind of looks like they're not going to be perpendicular because it doesn't look like they intersect at a right angle. So let's get the slope of Q, R. The slope would be 8 minus 2 over -1 minus -6. So 8 minus 2 is 6. -1 minus -6 is 5. The slope of ST is going to be 5 minus 6 over -8 minus -3. So 5 minus 6 is -1. -8 minus -3 is going to be -5, which is equal to -1/5. Now the slopes do have an opposite sign, but this slope is not the flip of this one. Okay, so since the slopes are not, this is how you would say the answer, the explanation. Since the slopes are not opposite reciprocals, the beams are not perpendicular. Okay, pretty cool. When you can determine whether the graphs of two linear equations are parallel or perpendicular by comparing the slopes of the lines. So determine whether the graphs of y equals 5 and x equals 3 and y equals -2x plus 1 are parallel or perpendicular. Explain. Well, first, let's graph them. Y equals 5 is a horizontal line going through 5 on the y-axis. So you go up 1, 2, 3, 4, 5. So horizontal line there. X equals 3 is a vertical line going through 3 on the x-axis. So right there. And y equals -2x plus 1, slope-intercept form, so I plot the y-intercept, which is 1. and use the slope. The slope there would be -2 as a fraction, -2 over 1. Remember, that's rise over run, so I would go down 2 over 1, put a point, oops, point right there. And then I'm going to do a couple more. Down 2 over 1, put a point. Down 2 over 1, put another point. And I'll do a couple backwards ones, just because more points helps me to draw it more accurately. And that's your line right there. Okay, now it looks like this vertical and horizontal line are perpendicular, and that's true. Vertical and horizontal lines are perpendicular. And it does not look as though anything else holds up there. It does not look like anything else. It's going to work out. So we graphed each line on the coordinate plane. From the graph, you can see that y equals 5 is parallel to the x-axis, right? And x equals 3 is parallel to the y-axis. Y equals 5 is parallel to the x-axis. I think I said that backwards. And x equals 3 is parallel to the y-axis. Therefore, those are perpendicular, and none of the lines are parallel, okay? Because the slope of this line right here is -2. The slope of y equals 5 would be 0, and the slope of x equals 3 would be undefined. So your slopes are -2, 0, and undefined. None of those are the same, so none of the lines are parallel. You can't really talk about any of them being opposite reciprocals, but vertical and horizontal lines are perpendicular, so those two are perpendicular. Okay, so here's one for you to try. Determine whether the graphs of 6x minus 2y equals -2, y equals 3x minus 4, and y equals 4 are parallel or perpendicular, and explain. Go ahead and pause the video. All right, we're back. So you don't even really have to graph these. So if you look at y equals 4, the slope of y equals 4 is going to be 0 because it's a horizontal line. The next one, 6x minus 2y equals -2, you have to solve that for y, so subtract 6x. So it's going to be 2y equals -6x minus 2, and then divide everything by -2. And you would get y equals 3x plus 1. So that has a slope of 3. And then this third equation is y equals 3x minus 4 is already solved for y, so its slope is 3. So I know that the first two equations have parallel slopes because the slopes are the same. None of the lines are perpendicular because none of the slopes are opposite reciprocals of each other. Okay, the opposite reciprocal of a slope of 0 would end up being a slope of undefined, and perpendicular slope for a slope of 3 would be -1/3. Okie dokie. All right, you can write the equation of a line perpendicular to a given line if you know a point on the line in the equation of the given line. Similar to how we did parallel, but we just have to do a little thing with the slope. Okay, so write an equation in slope-intercept form. Notice slope-intercept. For the line that passes through -4, 6 and is perpendicular to the graph of 2x plus 3y equals 12. Okay, so step 1, find the slope of the given line. It's not in slope-intercept form. It's not in point-slope form. It's in standard form. So I have to solve it for y to get it in slope-intercept form. So I'm going to subtract 2x from both sides and then divide both sides by 3. And I would get y equals -2/3 x plus 4. So therefore, I know the slope is -2/3. It's the number in front of x. Second step is the slope of the perpendicular line is the opposite reciprocal of the slope of the given line. So the opposite reciprocal of -2/3 is you flip it over, change the sign. So it's +3/2. Now we can find the equation of the perpendicular line because I know a slope and they gave me a point. So start off with point-slope form. Plug in what you know. Notice this is minus a -4, so we're going to rewrite that as +4. Distribute. And when you distribute the 3/2, it becomes 3/2 x, and 3/2 times 4, you could write the 4 over 1, and that becomes 12 over 2, which gives us 6. Okay, that's how they got the 6. Then add 6 to both sides to solve the equation for y, and you have y equals 3/2 x plus 12. Okay? If they had asked for point-slope form, we could have stopped right here. But they asked for slope-intercept form, so we had to distribute and solve for y. And this is why our answer is y equals 3/2 x plus 12. All right, so here's one for you to try. Go ahead and read it and pause the video and hit play when you're ready. Okay, we're back. What you get? Well, the given line is already in slope-intercept form, so I know the given line has a slope of 2/3. So the slope of our line, you should flip it over and change the sign. Now, I got y minus 7 equals slope, -3/2 times x minus 4. And they wanted it in slope-intercept form, so I have to solve that for y. I'm going to distribute the -3/2, so it's going to be -3/2 x. Now, -3/2 times the -4 is going to make it plus, and it would be 12/2, which is 6, so that's y minus 7. Then you add 7 to both sides, and you have y equals -3/2 x plus 13. Okay, and if you double check, the slopes of the two equations are opposite reciprocals. In other words, you flip it and change the sign and you get the other slope. All right. Okay, well that's it for this video lesson series for section 4. Please continue on to your assignment, and as always, reach out if you have any questions, and take care.